Well, hi, and welcome to my shop on another cloudy, rainy day here. It's March 13th. At the end of the last video on this radio, I said something about all that's left now is to do the alignment, and then the video ended, something like that. But in actual fact, I carried on, and I did complete the alignment. Well, I completed it wrong. The first part, the IAF alignment, where I'm adjusting these transformers, that went fine, and I'm gonna just put that video from yesterday right after this, so you can watch the alignment of the IF. But then after that, when I started the RF alignment, I made a big boo-boo, and I had the capacitor turned the wrong way while I tried to make the adjustment on an inductor here. It was a real struggle adjusting this thing, because I was adjusting this when I should have been adjusting the capacitor over here. I ended up just destroying the RF alignment of this radio. And I destroyed my willingness to continue with it, so I stopped at that point. So I'm going to stop here today, and then you're going to watch yesterday's effort on the IF, and then we'll be back here today. I'm going to redo the RF alignment. I've learned from my experience in doing these kinds of things that the first time, for me anyway, I attempt an alignment, I write the results off to education. It's basically a learning process first time through. Second time through, you can get more serious, more precise, and more careful about what you're doing. So, okay, so here comes the IF alignment. Okay, so we're going to be feeding a signal at the radio at 455 kilohertz. Here you see 455 here. So that's what's coming out of the signal generator on this wire to this coil, and that's the end of it. There's no connection between the generator and the radio except electromagnetically through the coil here to the antenna. The antenna on this radio is actually up in the lid here. So up in here. So hopefully this is enough. If not, we just rearrange it a bit. 455. Yeah, it may not be enough. We're going to give it a go. Okay, so I'm going to turn on the radio now. Since the radio is barely working, it could be something so serious, it's not going to work. No matter what I try. Okay, so we're at 103, 107. 112. Good. Don't hear a thing. So I'm going to vary the frequency of the signal generator over here. We'll see what happens. Not a thing. Okay, so we're going to putting the strongest signal I can into this coil. Nobody home. So we're going to put the coil, I'm going to couple it closer to the antenna, like really close. Like how about right there? Oh! Bingo! Bingo. Okay. Take it down a bit. Nope. Up. Tune it. Okay, take it back up. Ho ho ho! So it looks like the IF is tuned to two different frequencies, completely out of alignment. I just got to bring it back till they line up. Great. So this one's at 450, and this one's at 465. It could be this or this. It could be, who knows? Who knows? Let's do this. I'm just going to do it by ear. Not by instrument right now. Start with the second IF. Just listening. And we're on 453. Let's put this to where it should be, 455. You know what? I'm going to have to use a screwdriver. Hello?
Oh, hi, that Jim?
Yes, it is.
Jim, it's Kim calling from the doctor's office. How are you?
I'm very good.
Good. So I have a schedule for June 30th. Let's see what time I've got here. I am booking for 10:30 in the morning, June 30th, and that's dose number 2.
June 30th. At what time?
10:30.
10:30. April, May, June. Oh, that's a while from now.
Well, when you got your initial dose, you were told it was going to be 16 weeks. So, yeah.
Yeah. No, I'm not concerned at all. I'm following all the
Yeah.
media on this, and from what I can see, the effect of the shot I got only increases as time goes by.
Yes.
Yeah, that's what
The
they've
most
noticed.
recent literature I have copied, 14 days after your AstraZeneca dose 2, you're showing 100% efficacy.
Are you serious?
Which
14
is
days?
crazy. Yeah, that's what it says after dose 2.
Oh, after dose 2.
Yes.
Well, even after dose 1, what I heard, and I mean, I know all this stuff is still being researched and watched, and that was after 4 months, because some people have been on it for 4 months,
Yeah.
their level of antibodies is even higher, and it's continuing to increase. So even one dose seems pretty good. Okay, well that's good. Well, I'm wearing my face mask and being safe anyway.
Exactly. That's what you got to keep doing until we get enough people vaccinated where we can start seeing some herd immunity. So
Yeah.
let's keep our fingers crossed.
Yeah, no, we don't have to cross our fingers. Just keep working hard. It's going to happen.
Keep working hard. You got it.
Yeah,
All
okay.
right. I will see you on the 30th.
Okay, thank you. Bye.
Okay, take care. Bye-bye.
Okay, well, there we are. I'll let you listen to that. That just came totally out of the blue, although the date I kind of anticipated. Okay, back to what we're doing now. Just while we're on the topic here, my wife is scheduled for her first dose end of this month. Okay. I'm all excited. Uh-oh. Not like that. One was perfectly right, the other was quite wrong. Oh, wow, that's pretty sharp. Okay, just done by ear. Now, did that get us a radar that works? Let's find out. Sounds better. Definitely something goes on right here. We don't get anywhere with it. There's the hum. I think the hum is better. It just seems strange to me that it comes to life right at the very end here, very consistently. Doesn't seem to matter what I've done to the radio. It's not a short in the capacitor, is it? Doesn't seem like it. don't think so. Okay, so those were off a fair bit. Now, I guess we just carry on with the rest of the alignment. Again, hopefully I'll find something out of sorts with the radio, or it'll just spring to life. I'm going to read that alignment paper. Well, let's start here with a review of the instructions. See if I can figure out why I got this wrong. RF alignment. Loosen locking nut on oscillator adjusting screw which protrudes through the chassis between the control shafts. Okay, that's true. I did that. In doing that, I discovered that somebody previously tried to adjust this without loosening the locking nut, and they broke the screwdriver slot that's on the end of the rod that sticks out. That made things tough. So first thing you do is you loosen the nut. With tuning condenser closed and signal generator at 540. Okay, so I was going wrong already here because adjust oscillator screw. Okay, there's where I went wrong. So first I have you loosen the nut on the oscillator adjustment coil, then they draw your attention to the other end of the situation and have you do the other end. I just never got off this oscillator coil. I just kept fiddling with it, so that's how I went wrong. Okay, so with the condenser closed, signal generator 540, adjust oscillator screw, and that's on the capacitor. So that's completely what I did wrong. Did I do this wrong? Maybe I didn't. I don't know what I did. I did something and it didn't work out, so I'm going to do it again. Let's just keep reading through here. Next, with the tuning condenser open, generator at 1650. So these numbers, 540 and 1650, are the limits of the capacitor. They're not a spot on the dial. Adjust the oscillator trimmer. Oscillator screw. Oscillator trimmer. Okay. On the side of the front tuning condenser section, when do you get around to this little coil that you took the locking nut off? Therefore, adjust oscillator screw. Next, with the tuning condenser open all the way and the generator set to 1650, adjust oscillator trimmer. Well, no wonder I got confused. This is confusing. Repeat the 540 adjustment, leaving the oscillator trimmer unchanged. And so on, until neither one requires appreciable readjustment as the dial is turned from one end to the other. So you're just going back and forth, because each adjustment, although it's targeting one end of the range, it's affecting the other end a little bit too. Now set the generator above 1400, adjust antenna trimmer on side of rear gang. So we're doing a capacitor and a coil for the oscillator, and then when we're done, we're doing the capacitor, the trimmer for the antenna. This will usually be at or near the minimum trimmer capacity. Should it be impossible to reach a peak, then tighten the oscillator trimmer slightly. Try again. Okay, I think I know what they're up to here. Dial setting is moved to appreciably necessary to readjust the low end by means of the oscillator. Boy, oh boy, boy. So this is definitely a go around, around, around. This is definitely a go around thing. Okay, where do we start? The nut is loose. Yeah, I'm loose. I'm loose in my shop here. The tuning condenser closed. I'm going to do that right now. Okay, tuning condenser is closed. Dial's pointing at 540. Adjust the oscillator screw. Well, okay, so the screw, when they say screw, I think of a screw with a screw head, so I'm thinking of what's inside the IF cans. Well, that doesn't make sense. That kind of screw, anyway, like what's on the side of the capacitor. But when they say screw, they mean the slug. trimmer. That's what it must mean. So maybe I did this right. I don't know what I don't know what I did. What did I do? I don't know. Holy smokes. Holy smokes is right. I got myself thoroughly confused. That's a good way to be when you're going to do this work. Totally confused out of your brain. Okay. A little more light on the topic here. I have my signal generator running for a while, so it'll be stable, although my signal generator is very stable. This military one here is a super stable generator. So I want the output from that. I'm feeding it to this coil. The coil is near the antenna, so the signal is picked up by the radio that way. We want to do 540 here. 540. 540 being the very end. So I'm going to set this to like 560. I have the feeling that when we get to the end we won't find it anyway. We'll see. So we should be able to pick it up somewhere in here. Okay, volume is up a little bit. Radio is ready to go. Okay. Still through the dim bulbs. This is an almost instant on radio. Come on down here. What happened? It's probably warming up still and drifting a bit. That's what you're hearing now. I can hear the signal generator. So I'm wondering if is that a short in the capacitor plates making that? Sure seems like it. Okay, so right at the end of my session yesterday when I gave up on the RF, the last thing I noticed was the capacitor itself was unstable. And I began to attribute it to the way it's mounted on the chassis, that it's a little bit loose. And then I just said, well, that's enough for today. I packed it in. So we're right back at that spot now. What happened? And it wasn't doing anything at that moment. Okay, something's intermittent in here for sure. I'm going to set up the close-up camera for a very close look at the plates and the capacitor. Okay, so you can see my camera right up close to the plates, the light coming down from above. Let's take a look at what we can see now in here. I'm going to move the camera along so we can look right down each individual plate. Just a little closer. Second plate, third plate, fourth plate. Boy, they are close. They're always really close. Fifth plate, I'm looking way down in there. Nothing way down there to contact with. Sixth plate. Dirt's not helping, is it? Oh. But what is that we're seeing there? It's just a strange reflection. You may not know what I'm talking about. So I'm going to tune a little bit now. Can it just be all that dirt in there? So you can look at the. I sprayed a little WD-40 on here, but I didn't do the. Listen to the thing drifting around on its own. Those son of a gun, the little balls in there. Yeah, I can't think of what they're called, for crying out loud. I should put a little oil in there for sure. I don't hear the scratchiness now. Well, it's a lot happier when the plates are separated. They do appear to be very, very, very close. Okay, so I'm going to try and clean these off. Like a long paintbrush with long bristles getting in there. We'll see if that makes any difference to the situation. See the dust flying here. I don't know if these are going in very well. I don't think they're going in very well. Let's try this one. This is much better, I think. Yeah. Certainly a lot cleaner. You hear the tone. I've got this tuned right the wrong end of the band. Pretty quiet down here. It's kind of a sudden thing. It's an oscillation, I think. So when the set oscillates and produces an oscillation that you can't hear, either an unmodulated one or the tone is out of the range of the radio's audio system, that signal can still trigger the AVC voltage, and the radio's output volume can go up and down. And this mysterious change of volume is really a response from the AVC. And that's what I think we're hearing here. As I flip through this spot. Oop. Right there. Right there. you could even hear the output level as I crossed it just drop down suddenly and then come back up. There's a big chunk of something goes into the detector. So we got a totally different radio up here. A different radio up here than down here, where it's quiet. Just from crossing that point. So the question is, what exactly is oscillating? So we're varying these two capacitors here. Something to do with the circuits they're involved in. So it's possible too the oscillation is happening in the IF, but I don't think that would be the case this way. Don't know, it's hard to say because the oscillation can develop in one part of the radio and be transmitted over to another to come through, be amplified, and you get the oscillation thing going on. It can be in all kinds of patterns as far as I know. Well, let's put it in the quiet mode and we'll fool with some stuff. Right there. Right there. I'm going to turn it back a little bit. There's a hysteresis in this too. I'm going to turn it back a bit. Now, we'll see if I can touch something and trigger it. So I'll try retuning the IFs here. Okay, so all I did was bring this close to the IF. I didn't even touch it. I was just about to say something about if I touch it with a metal screwdriver, that might be enough. I didn't. Oh, there it's gone again. Is that a coincidence? That was a coincidence, or I had this closer to the edge? Right on the edge. Must have been a coincidence. So the oscillation is passing through the IF, and so it's coming out the far end of the IF and then somehow getting back through the radio. And then fooling with these could settle it. I just don't understand why it would be related to the dial, but the radio's, you know, it's supposed to do certain things. It's capable of doing all kinds of other stuff. All kinds of other stuff. Is it just a coincidence? It's hard to see what I did there, but I actually just put a little pressure on those cans, like just a little bit of pressure, and triggered it again. Now there's a warning in the manual about these kinds of things happening with this radio. Let's read it again and see, and just see. Okay, so these warnings are up here. Just turn the radio down a bit more. IF transformers to be aligned at 455. Feed the signal to set. Place the output lead of a signal generator on or close to the loop antenna, and I just set up another transmitting loop myself. Do not connect the ground lead of the generator to the chassis. If the IFs are badly off and signal cannot be heard, connect generator temporarily. So pound in a signal till you can hear it is what they're saying here. The grid lead goes to the side of the variable tuning capacitor. Tuning condenser. Tuning capacitor. Why did they say that? Temporarily to the grid end of antenna by means of the lug on the inside of the case. And then here's the hint. The grid lead goes to the side of the tuning capacitor. Okay, I'm not worried about this because it's not that bad. I'm not going to be following this little procedure. Tune the IF transformers for maximum output by means of a small insulated screwdriver starting at the nearest. I did all that. Set. Here we are. If set oscillates or hisses excessively, slightly detune one side of one or both IF transformers until trouble disappears. It's kind of what I'm doing. So that's it. Well then, what it might be suggesting here. Well, let's try this too. Let me feed I'll get on the sensitive side of this problem. 1300. Okay, I'm going to dial up 1300. This is just to verify what I think is happening is really happening. 1300. And the radio's alignment is way off, so what's really going to happen here? So get an idea of the strength. I'm going to turn this up one notch. Okay, get an idea of the strength here. Pretty good. Let me turn the radio up too. You can hear the ABC quieting the radio. Good. Now we're going to try the same thing up here. Let's say 800. So we'll dial in 800 and see what we hear. Well, I suspect we're going to hear next to nothing. 800. You know what? 800 is outside of the range of that scale. Okay, so I'm going to put the radio up around, well, just above 9. I have to change scales here. Just above 9. Yeah, see, we're not going to know for sure what's going on. So I'm going to put it back to where it was, 8. We'll have to go down a scale. I got to turn this dial forever. Oh. So that's the IF. Pretty quiet. Right past it. So what I'm suggesting is happening here is that in this part of the dial band, there's an oscillation we cannot hear that is setting off the detector, and we're getting an ABC voltage, and it's quieting the radio right down. So all we hear is what we can't hear, and we can't hear the signal even from, this is a pretty strong arrangement I have here to feed a signal to the radio. So the thing, it really does convince me that's true, there is an oscillation. Now I'm going to try to break that oscillation first by messing up the IAF alignment. Something terrible. Okay, we got the radio. No, the radio is not turned up very high. Okay, let me turn up a little higher and just try again. Over here. No. So what this is suggesting is that noise we're hearing is so strong that it's overcoming the weakness of the radio, and that I don't find that surprising. The noise signals are very, very strong. Same noise everywhere. Is there another spot? Is that another one? I don't know. So that's around 1600, and the oscillator is putting out 800 strong. So that's just a harmonic. Yeah, it's quite clear. Just you can hear it just disappear right there. The volume control is affecting it. Seem to have a mind of its own there. Okay, we're in the quiet area. So what I'm thinking is if I break the oscillation, then the radio will become loud. That sure didn't work. Well, I don't think it's going to work. What if I put the... oh my gosh, this is as tight as can be. Did I not turn this one? Wow. Well, never burst into life. We're at about a million. Okay, so another approach here. I make the assumption the reason this set is oscillating, appears to be oscillating, I better stick with that, appears to be oscillating, is it's because it's not aligned properly yet. If I just get it aligned properly, all this nonsense will just go away. God, what an idiot. I've been working here by a factor of 1,000,000 off or something stupid like that. What a bozo. Okay. 1400. Got myself way up into stupid frequencies. 1400. Oh my gosh. Da 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 da. Okay, I got way off track there and started fooling around with ridiculously high frequencies. Just got myself confused a little bit. So, okay, back in the saddle again. So we're dialed up to 1200. We have 1200 on here. And what I want you to listen to is as I tune the signal generator up and down, you'll hear a heterodyne pitch changing. So that can only happen if the signal generator signal is beating against some other oscillation. As it's passing by, it's doing that. Only not a hissy sound, it's an actual tone. Only I can't whistle that well. Something like that. And the reason for spotting that is that's proving there's another oscillation in the radio. If it was another... could be due to just there's a signal being picked up normally by this radio, maybe a noise signal presenting another signal in the IF, and then along comes my signal generator. Maybe that's where that tone is coming from. It would be true everywhere if the first thing I said was true. So we'll go to a quiet spot here. Yeah, no heterodyne. Well, there's a little one. But that's probably always the case. Come to think of it. And what are you trying to do, Jim? I want to find out why when I dial it over to 900, nothing comes out of this radio. That's what I want to know. Wow, this could be a real tough one to figure out. Now, I did put in an undersized capacitor. I replaced this big honker with a nice big 1 on it with a 0.5. Is that enough to cause this problem? It could be. I don't know. I'm going to double up that capacitor and see if this problem goes away. Grasping at straws. That's kind of what I'm doing here. Well, I found something very interesting here. So you can see this. Yeah, you can see this clip lead here, and that's connected to this cable, which is the input to my SDR radio, which you can't really see, but it's back here. So I'm going to flip up on the screen what the SDR radio is seeing from this radio, from this coil, where it's positioned. Okay, so you're looking at the SDR screen display here, frequency display. This is the AM radio band. You can see one very strong signal on here, and that's this. This is the local oscillator in the radio. The radio is currently tuned to around 1400. So if we take 455 from 1400, let me make this easier. Let's see, the radio is tuned to 1455. Well, that's easy. It means it's tuned to 1 million, in fact. So I'm going to swing my signal generator to 1 million and see if we don't hear it. And I can't get to 1 million here. And there it is. Well, that's 1500. 1500. Oh, I made a mistake here in my calculation. So if we take the local oscillator here, forget where the radio is, dial is set. It's at 2 million. So if we take off 455, we get 1550 or something like that. And my signal generator is running at 1583 right now. So the dial says, yeah, that's not bad. The dial says around 15. Okay, I just made a bad calculation there. So we're tuned right in this range. Now I'm going to tune the radio downwards across the band, and you just keep an eye on this. And I'm just going to keep tuning it downwards. And we'll see what happens here. We go. Here we go. Going down. Just going down steady. Okay, now something really weird there. What? Whoa, what happened? What? I'm still tuning the radio down. Just going down. Down, down, down. We're down. We're just about the end now. About 600, 550. There's the end. Oh, wow, that really was the end. I'll bet you the capacitor shorted right at the very end there. So I'm just going to back it up a little bit until it reappears. Back it up. No. You know what? I got to go a lot. There it is. So what's happened is it's broken into oscillation. Now on the SDR, you can see along with the strong signal here, you can see some other things here, and there's some other stuff over here. My best advice is just ignore all that as a effect of the SDR. So just ignore it. Now I'm going to tune the radio up in frequency. So right now it's tuned to 700. So local oscillator should be around 1100, but look where it is. It's at 1750. Keep tuning up, up. Notice I don't hear anything from the radio. Up, 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 and whoop, I'm going up, but it's starting to go down. No, it's standing still now. Okay, I'm right around a million on the dial, and you can hear I'm just moving the dial back and forth ever so slightly. You can hear it coming to life. Okay, continue down, Now from here the oscillator behaves rather normally. It just goes down as I tune, up and down. There we're crossing the where it's tuning in 1500, right there. So the problem here is the oscillator itself is misbehaving. I'm glad I put this on the screen. Well, I don't know how I would have ever have come to grips with this. I'm not really come to grip. There we go again. So I've just been tuning it in one direction, but you can see the oscillator has a mind of its own here. Of course, once the oscillator breaks from its proper frequency, the radio is then trying to tune frequencies that it's not actually tuned to. The front end is tuned somewhere else. Meanwhile, the oscillators try to pull out, trying to convert the wrong frequency. That's what I really want to say. Well, what do you do about this? And the thing is, it works normal. Like, it looks pretty normal to a point. Just look at the size of it, the strength of it. So it's right off the scale here. It's no longer off the scale. Once we're on the other side, it's weaker. No wonder I haven't been able to align this radio. Wow. Well, that's revealing. So just so you know what I was doing here, I was just tuning this back and forth while I was talking. This is the spot where the strangeness happens. Up here is normal. There's the 1500 oscillator signal. But when I get here, craziness ensues. Oh boy, I'm so glad I put this. You know what? This SDR just saved my life in a sense. I already wasted a lot of time on this. Should have got the SDR into the game right away. As soon as there's some weird thing going on, time to look at some signals using the SDR. Well, I'm going to end it here, and I'm going to end it for a while. I'm going to put this radio aside. I think this kind of problem is very hard to track down. I was going to put this radio aside. It's probably going to be away for quite a while I deal with a whole raft of other radios that have shown up here for work. So I think I got kind of the information I need out of this. What's the solution? I don't know. I think it could still be maybe a part is in there wrong, or a part is missing out of it. I don't know. Okay, so thanks a lot for watching the series to this point. Sorry it's kind of ending here for a while, but I have to do what I have to do. Next radio's a big honker. See ya, and thanks a lot for watching.